Okay, in this video I want to talk about the origins of mutations. This can be a little bit confusing, so I want to go through it little by little in hopes that we can build skills to analyze these kinds of questions. Okay, so here are our very ugly toy people with our diploid genomes and our haploid genomes that we saw on the previous slides. I do want to apologize. I know it gets kind of weird and ugly looking, but I hope it helps us understand. Okay, so what I've depicted here, don't worry about the X's, that's where we're going to talk about in a moment. What I've depicted here is a mating between two different people giving rise to an offspring, right? So this would be the mother or the father, and this would be the other parent, and this is the baby. So I want to talk about three kinds of mutations here. So the first one is inherited. So what we mean by an inherited mutation is a mutation that's present in one of the parents that gets passed down into the egg cell or the sperm cell, which then is inherited by the offspring. And so therefore will be present in all our diploid cells, and then in meiosis it'll get passed down in some of them. Okay, so the second kind of mutation that can occur is in the germline. So here we mean a mutation that's not present in most of the cells of the parent, but that occurs during the in the history of the cells that give rise to the sperm and egg cells. So it's a new mutation in the germline. So the germline is the line of cells that gives rise to sperm and eggs. And so these cells will also be inherited in the offspring because they are present in the fused diploid. And so all descendant diploid cells will have this mutation. And then finally, we can have somatic mutations, and these are the ones that end up being dominant in cancer, that are important for the progression of cancers. So these are mutations that occur during the development or during the history of this person that we're looking at, and they occur in a single cell, and then are present in all the cells that are descendant from that cell. So in this case, it would be all the cells that are present in this individual's left arm. And so somatic cells, here we've drawn it in which it's only present in a small fraction of the cells. But it can also be the case if a mutation occurs very early in development, say when the individual is only a few cells, that mutation will then be present in all the cells that single cell gives rise to. So under those circumstances, we can have a mutation that is somatic, that did occur in the developmental history of this person, but that is still present in a large fraction of cells. Okay, so let's talk about a couple of important distinguishing characteristics here. So again, focusing on this individual, the offspring, what kinds of mutations do we expect to be present in all cells? Well, as we said, inherited mutations are present in the initial cell, and germline mutations are also present in the initial cell. So all the diploid cells should contain both inherited and de novo germline mutations. So let's not get confused here. You can see if we focus in on the germline that we see there are some cells that don't carry either mutation or that carry only one or the other. Well, that's because these cells are haploid, they've reduced, and so that would mean that this, if we go back and look at our meiosis outcomes, here we have two mutations. Our meiotic products can either end up with both of them or neither of them or just one. So that's why they're not present in all of these haploid cells. But we would expect both inherited and de novo germline mutations to be present in all of the offspring. All of the diploid cells of the offspring. And okay, so then the next question would be, which of these mutations can be passed down to the next generation? Well, again, both inherited and de novo germline mutations are present in all our diploid cells. So that includes the diploid cells that ultimately give rise to our meiotic products, to our sperm and eggs. And so that means both inherited and de novo mutations, de novo germline mutations, have an opportunity to be passed down to the next generation. So what about somatic mutations? Well, if the somatic mutation occurs over here on the arm, then the arm is not part of the germline. Arm cells do not give rise to sperm and egg cells. So in this case, we would not expect it to get passed down. However, the other kind of case that we talked about, where we can have an early somatic mutation, or just a somatic mutation that occurs in a cell line that's headed towards the germline, so then we can have a somatic mutation that can in fact be passed down. So we expect that inherited mutations definitely have an opportunity to be passed down. De novo germline mutations in the parent definitely have a possibility of being passed down. And with somatic mutations, it's going to matter whether most somatic mutations are going to occur in cells that are not part of the germline. But some mutations, early mutations or mutations in the germline, can be passed down. So I hope that helps to clarify our three different types of mutations, so we can get a sense of which ones are going to contribute when we talk about different kinds of conditions.